Sometimes we are given problems about arrangements which have some special conditions or constraints. For example, how many 5-digit numbers can we make from the digits 1 to 9 if digits cannot be repeated? Part 2, digits cannot be repeated, the number must start with an even number and be divisible by 5. Let's start with part 1. So we have the digits 1 to 9, and obviously there are 9 of those digits. We want to make 5-digit permutations or arrangements. There are 5 slots to fill. The only restriction we have is that digits cannot be repeated. So for the first slot, we can choose any of the 9 digits. So we have 9 choices. For the second slot, well, we can't repeat, so whichever one we've used before, we can't use it again. So we've only got 8 choices at this stage, and then 7, then 6 left, and then 5. So remembering the fundamental principle of counting, we have 9 by 8 by 7 by 6 by 5 possible arrangements. And if we work that out on our calculator, we get a total of 15,120 different arrangements or permutations. Part 2 is a bit more complicated. Again, digits cannot be repeated, but this time the number must start with an even number and be divisible by 5. So let's start by showing our 5 slots. These represent each of the choices we have to make. So let's look at the restrictions. Can't repeat the digits, must start with an even number, and be divisible by 5. Let's start with the idea that they must be divisible by 5, because that's quite a big restriction. If a number is divisible by 5, it must end in the digit 0 or 5. So in this case we're choosing from the digits 1 to 9, so the only digit that's really going to work there is the digit 5. So in the final slot we've really only got one choice. Also, the number must start with an even number. So how many of our digits are even? Well, 2, 4, 6 and 8. So that's 4 digits, so we have 4 choices here in the first slot. After that, the only restriction is that digits cannot be repeated. So we had 9 digits to start with. We've used up 2, so we've got 7 digits to choose from. And then for this choice, for this slot, we've only got 6 to choose from and 5 to choose from. And again, multiply these to find out the total number of arrangements. So 4 by 7 by 6 by 5 by 1. So if we do that in our calculator, it turns out to be 840 different arrangements. So because we've got all these restrictions, we end up with a lot fewer permutations. Let's look at another example. How many 5-digit numbers can we make of the digits 2, 3, 5, 7, 8, using each only once? And then we're given 5 different scenarios, 5 different sets of conditions. So let's look at the first one, where there are no other restrictions. So we're making a 5-digit number, so there are 5 slots to fill, 5 choices to make. The only condition is that we can't reuse any of the numbers. So we have 5 choices for the first one, only 4 for the second, 3, 2 and 1. And we multiply them. And that's equal to 120. So there are 120 different permutations for this scenario. Remember that 5 by 4 by 3 by 2 by 1 is also known as 5 factorial. And you can put that straight into your calculator and you'll get 120. In the second scenario, the number must be odd. Again, we have 5 slots to fill. We're choosing from the numbers 2, 3, 5, 7 and 8. And the number must be odd. For a number to be odd, it means that the final digit in the number must be an odd digit. We have 3 odd digits to choose from here, so we have 3 choices here. And why do we start with this one? Well, this is the most restrictive slot, so we always start with the one that's most restrictive, the one that's kind of fussy. Having dealt with that, we can now go back and make our choices for the other slots. So for the first slot, well, we've used up one of these digits, so we have 4 remaining. We have 3 remaining, 2 and 1. And now we multiply them. So 4 by 3 by 2 by 1 by 3. is 72. So there's 72 different arrangements or permutations which are odd numbers. Now let's try the third one where the number must be even. Again, 5 slots. This time the number must be even, so that means that the final digit must be an even digit. So we'll deal with that first. We're choosing from 2, 3, 5, 7 and 8. We've only got 2 even digits there, 2 and 8. So we have 2 choices here. After that we can go back and fill in the other slots. So we have 4 choices, 3, 2 and 1. Again we multiply as usual. So we have 4 by 3 by 2 by 1 by 2, which is 48. So there are 48 arrangements that are even. Slightly different than the previous one. Now looking at part 4, where the number must be greater than 30,000. We're choosing from 2, 3, 5, 7 and 8. Again we have 5 slots. For a number to be greater than 30,000, it mostly depends on the first digit. For example, if we choose a 2 here, there's no way that this number can be greater than 30,000. If we put a 5 or a 7 or an 8 there, it'll certainly be greater than 30,000. If we put a 3 there, it will be greater than 30,000 as long as we don't have zeros in here, and we won't have zeros here. So as long as it's a 3, a 5, a 7 or an 8, then the number is going to be greater than 30,000. So we have 4 choices here. For the next choice, well, we've already used one of these, so we only have 4 choices remaining. So again it's 4, and then 3, 2 and 1, and we multiply them, which turns out to be 96 permutations. Let's look again at part 5. So the number must be less than 50,000. Okay, less than 50,000. And we're choosing from 2, 3, 5, 7 and 8. Again we have 5 choices to make. For a number to be less than 50,000, it depends on the first digit. In this case, a 2 would work there, or a 3. A 7 or 8 are not going to work. The 5 is not going to work either. So we only have 2 choices. For the second choice, we've used one number, so we have 4 choices left, 3, 2 and 1. So multiplying 2 by 4 by 3 by 2 by 1, that's 48. 48 permutations or arrangements we call them. So that was a look at some arrangements that had restrictions. Thanks for watching. Talk to you in the next lesson.